use horizontal stretching and shrinking to graph function. If f is a function and k is bigger than 1, then the graph of y equal f of x, and it has the k value multiplied to the inside of the parenthesis. It's inside. Can be obtained by shrinking the graph of y equal f of x horizontally, and then multiplying each x value by 1 over k. So we will talk about how to multiply k value by 1 over k, how to multiply x value by 1 over k. But here I'm going to explain the graph here. The red color line is the basic function f of x. The blue line is a translated horizontally function. This one has a horizontal stretching, a horizontal shrinking. So the blue line represents the horizontal shrinking. Why? Because k is bigger than 1. When you have the horizontal shrinking, that means the new graph will near to the y-axis. The new graph, because the horizontal shrinking is kind of like the same idea. They squeeze to the center of the y-axis. So when you have the horizontal shrinking, it's near to the y. Another case would be when k is between 1 and 0. And keep in mind that here, your k value is a positive value, and just depends on whether it's bigger than 1 or between 1 and 0. So when the k multiplied to the inside of the function, inside of the parenthesis of the function, the k is between 1 and 0. In that case, you will have the horizontal stretching. So when you have the graph horizontal stretching, that means they kind of like stretch the graph horizontally, and then it will go wider, the new graph. So it will near to the x-axis. When you have the horizontal stretching. So the basic graph is f of x. The translated graph is the blue color line here. So it tend to near to the x-axis, go wider, because the k is between 1 and 0. Now we look at the example. We have to graph this function using the graph of the function y equal x squared minus 1. Okay, so now I'm going to put a y equal x squared minus 1. We know this is a quadratic function. So the basic function of the quadratic function is the U-shaped parabola facing up. And it's outside of the function minus 1. So that means it will go down 1 unit. There you go. So the green color would be y equal x squared minus 1. Now we have to translate this function into the 3x, everything squared minus 1. So the way we can perform this new translate graph by graphically, or we can create a table. So let me show you how do we do that by the table. So we have the xy, right? And y is equal to 3x, everything squared minus 1. Now with the basic function here, the x value, when we select the x value, we can pick the 0, 1, 2, -1, -2. But just because the translated function has a number bigger than 1 multiplied to the inside of the parenthesis, so we have to change the x value by 1/3. So now you need to get a new table, a new column that perform the 1/3 multiply x. So this column will turn to your new x value, new x-axis. So when I have 1/3 multiplied with 2, I get a 2/3, 1/3, 0, negative 1/3, and a negative 2/3. And now solving the y value, we have to plug in the 1/3 x into the parenthesis here. So when I have the 2/3, plug in here, do the square minus 1. And here is this one. So here, 3 and 3 cross out. You only have 2 left. So 2 to 4 minus 1, your y value is 3. When I have the 1/3 plug in here, 1/3 multiplied by 3, you get a 1. 1 squared minus 1, you get a 0. 0 plug in here. 0 multiply any number, turn to the 0. So your y value will be negative 1. When you plug in the negative 1/3 into here, you will get a negative 1. Negative 1 do square, it turns to 1. 1 minus 1 is 0. Negative 2/3 plug in here, you will get a negative 2. Negative 2 square is 4. 4 minus 1 is 3. So if you look at the y value, when you have the quadratic function, they come with a symmetric pattern, your y value. Based on your x value, when you have the same x value, but just one is a positive, the other one is negative. In that case, the y value, they are equivalent. So 0, 0, right? And this will be the vertex point. So you just record your graph by using the plot here. Let's see. So if I sketch the graph, I just go label the 2/3, comma 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. So 2/3 pair with 3. 1/3 pair with 0. 0 pair with negative 1. Negative 1/3 pair with 0. Negative 2/3 pair with 3. So now I combine all the dot here to sketch the graph. So this graph is the 3x everything squared minus 1. As here you can see, it's go sharper, right? The new graph goes sharper. It's near to the y-axis because it has a horizontal shrinking. So if you don't want to go with a table, you just want to graph the function by translate it, then you can use this green color line. Let me erase the orange one. Okay, so now I can translate this graph by using the technique. Because 3 is greater than 1, so I know it's a horizontal shrinking. So with a horizontal shrinking, the graph will tend to skinnier to the y-axis. So we will have this point is go skinnier. It will pass into 0, negative 1 as well. Like go sharper. Okay. So now we do the last section here. Graph the function using a combination of transformation. So the strategy for graphing using the sequences of transformation. So normally we go with the horizontal translation first, and then you do the stretching or shrinking, and then do the reflection, and then the vertical translation. But sometimes, depends on the question you have, as long as you understand the concept, you know the technique, how to translate it. Some people, it's not necessary you have to follow all the order sequence here. Okay, but this is an easier way to help you to recognize how to do the translate. Use the graph of the function f of x is absolute value of x to graph the g of x. 3 multiply x minus 2 plus 4. Now, we have to use the technique by translating the function of the parent function to sketch this one. So first thing is you need to be able to recognize which one is the parent function of your absolute value function. So we know it's a V shape, right? It passing through 0, 0. So this graph is the basic function of your f of x. Now we start to translate it by looking at the horizontal translation first, which means look at the inside of the parenthesis here. This is minus 2. So when you have the minus number inside of your parenthesis, that means we deal with a horizontal translation. So minus 2 go right 2. And then the 3 multiply to the outside of the function, or outside of the parenthesis, outside of the absolute value, outside of the square root sign. As long as the number is multiplied to the outside, that means we have the vertical stretching by 3 on the y-axis. And then you have the go down 4. Go up 4. Because it add 4 by the end. Okay, so this is go up 4 by the end. So we'll sketch a graph real quick. Go right 2, so I'm going to translate this vertex point to the right 2 unit. And then it has a vertical stretching by 3, so I know the V shape will go skinnier because it's stretch on the y-axis. And the last step would be go up 4. So we have to shift the graph 4 units up. So 1, 2, 3, 4. So this vertex point will shift up to the 2, 4. So the V shape will stay the same by just facing up. And the vertex point is at 2. From 2, 0 transfer to the 2, 4.